One of the many surprising findings in physics is that if you can neglect air resistance for objects that are flying through the air, horizontal and vertical motions are independent. Let's have a look at what this means in practice. What I have here is an object that is going to project this ball straight up in the air. Well, that's pretty easy to think about, but there's a twist, because I'm going to take this car and I'm going to send it running down the track through that extremely realistic tunnel that you see down the way. And so it's going to fly up just as it reaches that metal bar. And your question is, what is going to happen next? Is it going to fly up and then land perfectly right here in the middle of the cart? Is it going to fly up and then land way behind the cart? Is it going to fly up and land way ahead of the cart? Or will it end up in this cart, but only if pushed at a very, very special velocity only known to PhDs in physics? Okay, you've made your guesses. Let's find out. I take the ball and push it down into the spring. I focus on the special velocity, and it ends up in the cart. Let's try that again. I press it down, and it ends up in the cart. Well, let's find out if it only works when it's done by a physics professor. Could I have a volunteer here, please? And what's your name?
Caroline.
Okay, Caroline, could you please put that in, shove it down, and now focus. Are you focused? All right, push it carefully and let's see what happens. Perfect. Turns out it doesn't actually take a PhD in physics, it just takes the laws of physics for the ball to fly up and come right down into the cart. Here's why. Horizontal and vertical motions are independent. So at the moment the ball leaves the cart, it flies up, but the ball and cart have the exact same horizontal velocity. So as the cart moves along and the ball moves along, their horizontal positions are the same. And then when it comes down, they're in the same place, and the ball ends up in the cart. There are a couple other ways you might think about this. Imagine being in the cart. Suppose you were sitting in a car and throwing a ball up and down. It wouldn't surprise you that it ends up in your hand. But think of what someone sees when they're walking along from the outside. What someone from the outside sees is that the ball in your hand goes up, but it also goes sideways along with the car. It forms a parabola and then comes down in your hand, which is in this new location. The problem seems really simple when you're in a frame moving from with the car. It looks more complicated when you're looking from the outside, but actually both cases are exactly the same.